L equals I theta. Or wait, I omega.
Angular. Okay, momentum? Yeah. So angular momentum is L, denoted as L, kind of like how regular momentum is denoted as P, which doesn't make sense at all. That's how it works. So L,
I theta. Or I omega.
I omega. So L is your angular momentum, I is your moment of inertia.
Okay.
And your W is your angular velocity. Velocity. So this is in length to the fourth, and that is in radians per second.
Length to the fourth. What does that mean?
It actually depends on what it is on it. For example, if you're using, if it's in, oh, never mind. I take that back. Side note, like if you have a box that's base times height, the moment of the area moment of inertia is 1/12 base times height cubed. So it's going to be length times length times length times length. So like if this were in inches, your moment of inertia would be inches to the fourth. Those are the units of it. But it's not. That's not the I that we want. That's not the I we're looking for. It's the mass moment of inertia. Cool. So this is the mass moment of inertia. Okay.
Okay.
So that is equal to 1/2 mR squared. Now, we have two different sized disks. We have a small disk and a large disk. They both weigh the same. The only thing that changes is what? The omegas change and the R changes.
Mm-hmm.
So the R changes and the omega changes. This is 1/2 omega and this is 1 omega.
Okay.
And we want to find out which L is bigger.
Angular velocity. Okay.
And it's R, 2R, and it's R and 2R. Awesome. So your L of 1 is equal to I of 1. What's your I of 1?
I is the moment of inertia, so R1?
Yeah. So it's this one.
Mm-hmm.
So it's 1/2 m times R squared times your omega. Okay. Now L2, the angular momentum of the second. So you can put in the second moment of inertia.
Should
Be taking in the 2R and putting it there, and then the 1/2 W and putting it there.
okay, so then that would be 1/2 and R. So on our L1, that just looks like a standard equation that we'd use. We haven't plugged anything into it yet, have
Yeah.
we?
Well, we know what I is, and we know what omega is. It tells us that omega is omega, and your I is 1/2 mR squared. The m is going to stay the same, and the R is going to change.
Okay.
It says that this R is 2 times that R. So we know that we don't have the exact number, we know the relationship, so we can work around that.
Okay. So we'd have 1/2 m, and then our R is going to change because it's going to double.
Okay,
So
2R.
2R squared. And then our omega is going to be 1/2. So we'll have to make that.
Awesome. So now we can just simplify down. This comes to be just that, but this comes to be 1/2 m times 4R squared times 1/2 omega.
Okay.
That 4 will cancel those two out, because 1/4 times
Right.
1/2 times 1/2. Trevor, how you doing?
Did you bring me a donut?
I'm I've been at the store, I'm sorry.
Trevor.
And so that is the angular momentum of the second disk. M r squared omega. So which one's bigger? 1/2 mr squared omega or mr squared omega?